Hello students, welcome to another video of Chemphilia, and today we are going to start the JEE Advanced PYQ series, and the chapter is some basic concepts of chemistry. So in this video we'll see how to solve the questions asked in 1978 and 79. So we are actually covering the whole last 42 or 43 years questions of JEE Advanced, right? So the first question, 27 gram of aluminium will react completely with how many grams of oxygen, right? The options are given. So how to solve this question? Let us see. First, this is a question from stoichiometry. So we have to write the complete balanced equation, and the equation is 4 aluminium plus 3 O2 gives 2 Al2O3, right? So 4 moles of aluminium reacts with 3 moles of oxygen. Now aluminium, the atomic weight is 27. So 4 moles of aluminium means 108 gram of aluminium, and 3 mole of oxygen means 3 into 32, because oxygen's molecular weight is 32, that is 96 gram. So 108 gram of aluminium reacts with 96 gram of oxygen according to the balanced equation. So 27 gram of aluminium will react with how much oxygen? So it will be 27 multiplied by 96 upon 108, right? So the answer will be, let us see, 27 108, it's 4, so 496, it's 24. So the answer is 24 gram of oxygen. Clear? So this is the answer. So the correct option is option D. Clear? So option D is the correct answer to this question. So I hope you have understood this. Let us move on to the next question. The next question is, a compound was found to contain nitrogen and oxygen in the ratio 28 gram and 80 gram respectively, right? The formula of the compound is, 4 options are given. Now this is basically a question from empirical formula, because the formula that we are going to get from the ratio of mass, that is empirical formula, not the molecular formula. So however, whatever the formula has been asked in question, so let us try to find it out. Now first of all, that we will calculate, that is the ratio of nitrogen and oxygen's number of atoms. So we have to find out the ratio of number of atoms of nitrogen and oxygen, and the ratio, how to find out that? It's very easy. It's mass of nitrogen divided by atomic weight of nitrogen is to mass of oxygen divided by atomic weight of oxygen. It's so easy. So mass of nitrogen according to the question is 28 and its atomic weight is 14, is to mass of oxygen according to the question is 80 and atomic weight of oxygen is 16. So it's 2 is to 5. 2 is to 5 means the formula will be N2O5. So if N2O5 is the correct option, that means option C is the answer. Option C is the answer. Clear? So I think you have understood this question. The next question is what weight of AgCl will be precipitated when a solution containing 4.77 gram of NaCl is added to a solution of 5.77 gram of silver nitrate. So this is the question, right? So let us see how to solve this question. wait a minute. First, let us write the uh, reaction. Reaction, and we have to also find out the molecular weight, because here first we have to calculate the molecular weight. Okay, I'm writing in short. MOL means molecular weight of NaCl is sodium is 23, chlorine is 35.5, that is 58.5. Then molecular weight of AgCl, that is Ag is 108, chlorine is 35.5, that is 143.5, and molecular weight of AgNO3, that is 108 plus nitrogen is 14 and oxygens are 16 into 3, that is 170. Clear? So now we will write the reaction. The reaction is AgNO3 plus NaCl gives AgCl plus NaNO3, right? And AgCl precipitates, right? So it's 1 mole. It is also 1 mole. AgCl obtained, it's also 1 mole. So it means 170 gram. It means 58.5 gram. It means 143.5 gram, right? Now the thing is that how much NaCl is taken according to question 4.77, and how much AgNO3 is taken 5.77. Now the question is, do they react completely, or anyone is left? So that means basically this is a question of limiting reagent. Now how to find out the limiting reagent? It's very easy. First we have to take the ratio of masses of AgNO3 and NaCl. So we have to get the ratio of mass according to reaction, according to reaction, and that is 170 is to 58.5. Clear? Now one thing you must remember, when 59 is multiplied by 3, it becomes 177, and here it is 58.5 and the figure is 170. So almost it's 3 is to 1. It's almost 3 is to 1, we can say, right? And the same ratio, that again we will calculate. The same ratio means the ratio of masses of the same reagents, but this time according to question. According to question. Now according to question, how much AgNO3 is given? 5.77, and how much NaCl is given? 4.77, right? So it's, see, how to calculate this. 4.77, it can be taken as almost 4.8, right? Then do this thing. 5.77 you can consider it to be 5.8, and this is 4.8, so it's coming out to be almost 1.2 is to 1. Clear? So according to reaction, for one part of NaCl, how much AgNO3 is required? 3 parts. But according to question, as per question, for each part of NaCl, 1.2 parts of AgNO3 is given. That means the given amount of AgNO3 is less than what is required. So obviously AgNO3 is given in lesser amount. So AgNO3 is the limiting reagent. LR. LR means, remember, it means limiting reagent. Okay. Now limiting reagent has been identified, and that is AgNO3. So the amount of AgNO3 will decide how much AgCl will be produced, right? Now as per question, 170 gram of AgNO3 gives 143.5 gram of AgCl, right? So let us write this. 170 gram of AgNO3 gives sorry, 143.5 gram of AgCl. Therefore, 5.77 gram of AgNO3 gives how much AgCl? It will be 5.77 multiplied by 143.5 divided by 170 gram of AgCl. Okay, so it will be around 4.87. It will be around 4.87 gram. Clear? So 4.87 gram. This amount of AgCl will be precipitated. So this is the answer of this question. Now you know that how can we do these calculations? How to do these calculations in exam hall or within a short period of time? See, it's 143.5, right? And it's 170. Clear? So when 143.5, it can be taken as 144 by 170. See, 17 into 10 means 170, and 17 into 8 means 136. So it's almost 8.5 upon 10, we can say, because 17 into 8 is 136, and here the number is 144. So we can almost take 8.5 by 10. So 8.5 by 10 means 0.85, and this will be multiplied by 5.77. So quite obvious, the answer will be a bit less than 5.77. Clear? So in that way we can get the answer. So let us come to the next question. The next question is, igniting MnO2 converts it quantitatively to Mn3O4. A sample of pyrolusite, remember, it's an ore of manganese, is of the following combination, is of the following composition: 80% manganese dioxide, 15% silica, means silicon dioxide, and other inert constituents. The rest is water. The sample is heated in air to a constant mass. Clear? What is the percentage of manganese in the ignited sample? Clear? So this is the question. How to solve this question? Let us see. First of all, let us see the reactions. 3MnO2 is converted into Mn3O4, right, upon heating. SiO2, when it is heated, no change takes place, while H2O, which is in liquid state, upon heating it remains H2O, but its state is changed. It is converted from liquid to gas. Clear? And since H2 is converted into gaseous state, so it evaporates. Clear? So according to the question, after heating we get a constant mass. That means we get a residue. Now that residue contains, remember, Mn3O4, because Mn3O4 is a solid, and that residue also contains silica, because silica is unchanged. Clear? So the sample of pyrolusite, the sample of pyrolusite on heating left a residue containing Mn3O4 and SiO2, right? Now molecular weight of MnO2 is 55, manganese is 55, and 2 oxygens are there, there is 16 into 2 means it's 87, and molecular weight of Mn3O4 is 55 into 3 plus 16 into 4. So it's 229. So the molecular weights we have calculated. Now, if you look into the reaction, the first reaction, 3 mole of MnO2 gives 1 mole of Mn3O4, right? So we can say 3 into 87 gram of MnO2 gives 229 gram of Mn3O4, right? Therefore, now if you look into the question, how much MnO2 was there in the sample? 80%. So 80 gram, sorry, 80 gram of MnO2 gives how much Mn3O4? It will be 229 into 80 by 3 into 87 gram of Mn3O4. Now you can see 80 and 87 almost same. So it's basically 229 divided by 3. So it will be around 70. It will be around 70 gram of Mn3O4. So it will be around 70. And if we want to make it the proper calculation, it will be 70.2 gram of Mn3O4. Okay. Now the residue, sorry, mass of residue. So residue contains, Mn3O4 and SiO2. Now how much Mn3O4 we have got? 70.2 plus how much SiO2 was there? As per question, 15% means 15 gram. So it will be 85.2 gram residue. Clear? Now manganese is present in only Mn3O4, right? Now Mn3O4's molecular weight we have calculated 229, and how much manganese was there? 55 into 3. So we can say 229 gram of Mn3O4 contains 55 into 3 gram of manganese. Therefore 70.2 gram of Mn3O4 contains, it will be 55.3, sorry, 55 into 3 into 70.2 divided by 229 gram. So the calculation gives us a result which is 50.58 gram of manganese. So this is the amount of manganese, right? Now what was the mass of the residue? The mass of the residue was 85.2 gram, and how much manganese is there? 50.58 gram. Therefore percentage of manganese in residue, it will be mass of manganese, that is 50.58, divided by mass of residue, that is 85.2, multiplied by 100. Clear? So it's 59.37. 59.37. So this is the answer to this question. So the percentage of manganese in residue means ignited sample. You can see in the question it was asked the percentage of manganese in ignited sample. Ignited sample means the sample after heating. So percentage of manganese in the residue or the sample after heating, that is 59.37%. So I hope you have understood this question. So let us move on to the next question. The next question is 1 gram of an alloy of aluminium and magnesium when treated with excess of dilute HCl, forms magnesium chloride, aluminium chloride, and hydrogen, right? The evolved hydrogen collected over mercury at 0 degrees Celsius has a volume of 1.2 liters at 0.92 atm pressure. Now calculate the composition of the alloy. Clear? So how to solve this question? Let us see. First of all, uh, let us calculate the number of moles of hydrogen. Now it is PV by RT. You know the equation, PV equals to nRT. So we are getting this from that equation. We are getting this formula from that equation only. Now P is 0.92 atm, volume is 1.2 liter, divided by R means universal gas constant, it's 0.082, multiplied by T is 0 degrees Celsius, that is 273. 0 degrees Celsius means 273 Kelvin. So it's 0.0493, or we may consider it to be 0.05. So this is the number of moles of hydrogen that we have obtained. Now let us write the reaction. Magnesium plus 2HCl produces magnesium chloride plus hydrogen, which is released. On the other side, 2 aluminium reacts with 6 HCl to produce 2 AlCl3 plus 3 hydrogen, which is released. Now the total mass of the alloy was 1 gram, and that contains aluminium and magnesium. So let x gram be the mass of magnesium, therefore mass of aluminium is 1 minus x gram, right? Now one more thing, I must tell you that as per reaction, 1 mole of magnesium gives 1 mole of hydrogen, while 2 moles of aluminium gives 3 moles of hydrogen. Clear? So number of moles of magnesium will be mass by atomic weight. Mass is x, atomic weight is 24. Whereas number of moles of aluminium will be 1 minus x upon 27. Right? Now, as per reaction, you can see the number of moles of magnesium and number of moles of hydrogen in the reaction were same. So 1 mole of magnesium gives 1 mole of hydrogen. So we can write number of moles of hydrogen from magnesium is x by 24, right? Whereas number of moles of hydrogen from aluminium, now you can see 2 moles of aluminium gives 3 moles of hydrogen. So number of moles of aluminium is 1 minus x by 27. It has to be multiplied by 3 by 2 to get the number of moles of hydrogen. Now total number of moles of hydrogen is x upon 24 plus 1 minus x upon 27 multiplied by 3 by 2. And if you see the calculation, the first part of the solution, the number of moles of hydrogen that we obtained was 0.05, which means it will be equals to 0.05, right? Now how to solve this? First we have to take the LCM. It will be 216, so it's 9x plus it will be 54. 4 means 12 minus 12x is equal to 0.05, right? So if we solve this, it's coming out to be 3x 3x, it's minus 3x plus 12 is equal to, it will be 10.8, which means 3x is equal to 1.2, 1.2, that is x is equal to 0.4. Now what was x? X was the mass of magnesium. So we have got the mass of magnesium. So mass of magnesium, here we are writing mass of magnesium is equal to 0.4 gram, right? And mass of aluminium will be 1 minus 0.4, that is 0.6 gram. So these two are the answers to this question. Clear? So I hope you have understood this question. Next, an MCQ. The question asks the largest number of molecules. The largest number of molecules is in, four options are given, right? So we have to find out the number of molecules and we have to compare them to see which one has the largest number of molecules. So this is a question which can easily be solved. First, let us calculate the number of moles of water. The mass given is 36 and water's molecular weight, it's 18. So it's 2. Second option, 28 gram of carbon monoxide. Carbon monoxide is CO. So its mass is 28 and molecular weight will also be 28, that is 1. Now let us move on to the option C. Number of moles of ethyl alcohol. Ethyl alcohol is C2H5OH. Okay, the mass is 46 by molecular weight. The formula you have seen, it's C2H5OH. So its molecular weight is also 46. Okay, so it's 1. And option D, number of moles of nitrogen pentoxide N2O5. So it's 54 divided by, now nitrogen pentoxide's molecular weight, if you calculate, it will be 108. So it's 0.5. Now you know that number of molecules actually depends on is proportional to the number of moles, right? As the number of moles increases, number of molecules also increases. So whoever has the maximum number of moles, that will contain the maximum number of molecules as well. Now which one has the maximum number of moles? It's 2. So option A, that will have the largest number of molecules. So here you must remember, molecules number of molecules is directly proportional to number of moles. So if we get the number of moles and compare them, we can easily get which one has the highest number of molecules. Clear? So option A is the answer to this question. I hope you have understood this, and then let us move on to the next question. The next question is probably the easiest question of them all. The total number of electrons. We have to calculate the total number of electrons, right, in one molecule of carbon dioxide. Clear? Now carbon dioxide, it's CO2, right? Now we have to get the total number of electrons. Now carbon's atomic number is 6, right? So carbon has 6 electrons. Oxygen's atomic number is 8. 2 oxygens are there, so 8 into 2, it's 22 electrons. Clear? So option A is the answer to this question. 22 electrons are there in total in one molecule of carbon dioxide. Next, let us move on to this question is asking about a gaseous mixture that contains oxygen and nitrogen in the ratio of 1:4 by weight. That means it is the ratio of their masses, 1:4. And we have to get the ratio of the number of molecules. We have to get the ratio of number of molecules. In the last question, in the last to last question, I told you that number of molecules is directly proportional to number of moles. So if we get the number of moles and take their ratio, that will also be the ratio of number of molecules, right? So first, what we have to do, let 1 gram and 4 gram be the masses of oxygen and nitrogen respectively. Clear? So what is the number of moles of oxygen? Its mass by molecular weight. Mass is 1, molecular weight is 32. And number of moles of nitrogen, the mass is 4, molecular weight is 28. So it's 1 by 7. Clear? So number of moles of oxygen is to number of moles of nitrogen. So we are getting the ratio of number of moles, and it's 1 by 32 is to 1 by 7, which means 7 is to 32, right? Now as we know, number of molecules is directly proportional to number of moles. Therefore, oxygen is to nitrogen, we are getting the ratio of number of molecules. So the ratio of number of molecules will also be 7 is to 32. So this is the answer to this question. Option C is the answer. Clear? Now let us move on to the next question. The next question is 2.76 gram of silver carbonate on being strongly heated yield a residue weighing 4 options are given. So this is also a question from stoichiometry. That means we have to write the reaction first. Now silver carbonate, it's a solid which upon heating produces silver, which is another solid. So uh, it is a residue in this case. CO2, which is a gas, escapes, and half O2, that is oxygen, another gas, it also escapes. So you can see 1 mole of silver carbonate produces 2 mole of silver, right? Now what is the molecular weight of silver carbonate? Its molecular weight is 2 into 108 plus 12 plus 3 oxygens are there, 3 into 16. So it's coming out to be 276. So 1 mole means 276 gram, and 2 moles means 2 into 108, that is 216 grams. So quite clearly you can see 276 gram of silver carbonate produces how much residue? 216 gram. And as per the question, 2.76 gram silver carbonate will produce how much residue? So it will be 2.16 gram. It's simple maths. 276 gives 216, so 2.76 will give how much? 2.16. So option A is the answer to this question. Clear? I hope you have understood this, and then we are moving on to the next question. The next question is 4.215 gram of metallic carbonate was heated in a hard glass tube, and the CO2 evolved was found to measure 1336 ml at 27 degrees Celsius and 700 millimeter pressure. What is the equivalent weight of the metal? So that is the question. Clear? So let us see how to solve this question. First of all, we know that PV equals to nRT, and N means nothing but mass by molecular weight into RT, right? Now P means pressure. Pressure is how much? 700 millimeter. And let's convert it into ATM by dividing by 760. Into volume is 1336 ml. But if we want to convert it into liter, we have to divide it by 1000. Equals to W by M. M means molecular weight. Here the gas is CO2. So what is the molecular weight of CO2? 44. Into R is 0.082 into T is 27 degrees Celsius, that is 273 plus 27, right? So W is coming out to be, we are not going into the detailed calculation part, we are skipping that. So W is found to be 2.198 gram. 2.198 gram, that is the mass of carbon dioxide that we have got. Clear? Now let what is the question? We have to find out the equivalent weight of the metal. So let E be the equivalent weight of the metal, right? Therefore molecular weight of metal carbonate, right? Now see one thing, carbonate is a bivalent radical. Clear? So in this case for metal the N factor is 2. So if E is the equivalent weight in the metal carbonate, its atomic the mass of the metal will be 2 into E. Clear? Plus for carbonate it's 60. So 2E plus 60, that is the molecular weight of the metal carbonate. Clear? Now if we look into the reaction, the metal carbonate may be MCO3 or M2CO3. But whatever be the metal carbonate, it produces CO2. And you can see 1 mole of the carbonate gives 1 mole of CO2. It means the number of moles of the carbonate and carbon dioxide are same. The number of moles of these two things are same. So number of moles of MC means metal carbonate, is equal to number of moles of CO2. So number of moles of metal carbonate means its mass by molecular weight, its mass is as per the question its mass is 4.215 and its molecular weight is 2E plus 60. And for carbon dioxide, its mass we just now calculated 2.198 divided by its molecular weight is 44. Clear? So if we calculate, if we do the proper calculation, the equivalent weight will be near 12. If not exactly 12, it's near 12. So we may consider that 12 is the equivalent weight of the metal. Okay, so this is the answer to the question. And then let us move to the last question. 5 ml of a gas containing only carbon and hydrogen is mixed with an excess of oxygen. And how much oxygen is taken? 30 ml. And the mixture is exploded by means of an electric spark. The volume of the gas of the mixed gases becomes 25 ml, which means after the reaction the volume becomes 25. On adding concentrated solution of potassium hydroxide, the volume further decreases. The volume further decreases to 15 ml, and the residual gas being pure oxygen. Clear? All volumes have been reduced to STP. So all the data are taken at STP. Calculate the molecular formula of the hydrocarbon gas. So this is the question. Clear? So it's a question from eudiometry. It's a question from eudiometry, right? So let us see how to solve this question. Wait a minute. Now let CXHY be the molecular formula of the hydrocarbon. and it reacts with oxygen to give CO2 and H2O. Now, the hydrocarbon is a gas, oxygen is also a gas, carbon dioxide is a gas, but water that is obtained, just a minute, but water which is obtained after the reaction, it is a liquid. Clear? So we have to balance this equation. It will be x CO2, it will be y by 2 H2O. It means it's x plus y by 4. So if it's one volume, it will be x plus y by 4 volume. It will be x volume and it will be 0 since it's a liquid. Clear? Now, according to question, the hydrocarbon volume is 5 ml. So one volume is 5 ml. So x plus y by 4 volume will be 5 into x plus y by 4 ml, and it will be 5x ml. So all the volumes are converted into milliliter. Now, you must remember one thing. When potassium hydroxide is added, it actually absorbs carbon dioxide. So if there is any contraction after addition of potassium hydroxide, that contraction is totally due to carbon dioxide. Clear? So from this data we can get the volume of CO2. Clear? So before addition of potassium hydroxide the volume was 25 and after addition it becomes 15. So what is the volume of CO2? 25 minus 15, that is 10 ml. But in the reaction volume of CO2 is 5x. So therefore we can say 5x is equal to 10, that is x is equal to 2. So the value of x we have calculated. Now we have to get the value of y. Now how much oxygen we have taken? 30 ml, and after the reaction 15 ml is left, and that is totally pure oxygen. So how much oxygen is consumed? So volume of oxygen used is 30 minus 15, that is 15 ml, right? So that is the volume of oxygen used. But as per the reaction, how much oxygen is used? 5 into, you can say 5 into x plus y by 4, right? Therefore 5 into x plus y by 4 is equal to 15. It means x plus y by 4 is equal to 3. Now the value of x we have seen, it's 2. So 2 plus y by 4 equals to 3, that is y is equal to 4. So thus we have got the values of both x and y. So what will be the formula of the hydrocarbon? So we are writing it here. Formula of the hydrocarbon. Formula of the hydrocarbon will be what? CXHY. X is 2, Y is 4. So C2H4, this is the formula of the hydrocarbon. So I hope you have understood the solutions of the questions that I've discussed in this video. So if you like the video, don't forget to hit the like button and share the video, subscribe the channel. Thank you.